Alright guys, so obviously I'm not here today, so I'm just going to give you a little bit of notes on elements and compounds. You guys who were here Friday, you saw that video, we talked about it. There were 5 things that we wanted to talk about from the video. Can an element be broken down? What is a molecule? You got to give 2 examples. Do compounds have different properties than the elements that make it up? Can compounds be broken down? And then what is a compound? So we're going to kind of go through that. I'm going to give you notes, like I said, on elements and compounds. So this shouldn't take that long, maybe 10-15 minutes tops. So I'll write everything down that you need to know. Then you're going to have book work out of this book. This is your book. It's on the top shelf over there. And I'll write that on the board so you can do that. So I'll give you some notes, then you'll do the book work. But the book work is homework due tomorrow. So let's do it. All right, so elements and compounds. We'll start with elements. Elements are the simplest form of matter. Yes, elements can technically be broken down into protons, neutrons, and electrons. They're little tiny subatomic particles that make atoms up. But those little particles aren't considered matter. They don't take up space, not really, as far as volume, and they don't really have a mass either. They do, but it's very, 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 very small. So we say elements are the simplest form of matter. What does that mean? They're called the building blocks of matter. Building blocks, meaning you use elements to build everything else in the world, right? So all matter is made up of elements, right? So building blocks of matter, simplest form of matter. Put a little star. This is very important. Elements cannot be broken down. Elements cannot be broken down. So they are the simplest form of matter, right? Cannot be broken down. Physically or chemically. You can't break it down on an atom of an element. So, for example, this is lead up here on the desk. This is lead shot. Each one of those little tiny lead balls there has millions of lead atoms. If you kind of broke it down into just the individual atoms, you were holding an atom of lead, that is the simplest form of matter, and you cannot break that down any further. All right, so building blocks, simplest form, cannot be broken down. Another thing I want to show you here, it's hard to see maybe on the video, but in here, all the lead balls look identical to each other. In here, this is tin. Every piece of tin looks identical to every other piece. Give you another one example here. Over here, this silicon rock, it's an element. Every part of this rock, every atom is identical. So all atoms of all elements are identical. All atoms of an element are identical. That means they have identical properties. Have identical properties. They have identical properties. Physical and chemical. I'll put that in parentheses. Physical and chemical. Physical and chemical. So, physical, what it looks like, right? The density. Chemical, how it reacts with acid, how it reacts with the air, stuff like that. All atoms of an element are identical. Another star, very important. Elements have what's called uniform composition. Uniform composition. That means what it's made of, right? Composition, what something's made of. Uniform means it looks all the same. Think about kids that have to wear uniforms to go to school. The point is to take away, personal clothing so there's no difference, right? That's the theory behind it. So everybody looks the same. So uniform means they look the same. Composition, what they're made of. So all elements okay, one sample of an element, for example silicon, is uniform. It all looks the same. And that stems from this. All atoms of an element are identical. Okay? So uniform composition cannot be broken down. Building blocks, simplest form of matter. And examples of elements, you don't need me to write them down. They're over there on the wall. We've talked about elements all year, so you know what the elements are. Let me look at my notes, make sure I'm not forgetting anything. One more thing I would like to add here. I guess another star. All atoms of the same element have the same number of protons. What is that? The atomic number. So in other words, if we look at oxygen, okay? Oxygen has atomic number 8. That means it has 8 protons. That's the protons. All atoms of oxygen have 8 protons. Any atom of oxygen anywhere in the world, if it's pure oxygen, just one atom of oxygen has 8 protons. That's what that means. If that's a little confusing, that's okay. We'll talk more about it down the road. All right, your homework is more on the stuff up top here. That's just kind of an extra one. So I'm going to give you another minute or so. Copy that down. Then I'll go through compounds, and then you can do your bookwork. A minute feels like a long time when I'm just standing there by myself in a room talking to a iPad. Ten seconds. So hopefully you got all this down. A lot of it we saw on that video last Friday. Okay, here we go. So that's elements. Where am I? Elements. Compounds. Here we go. Compounds. What is a compound? You may know or may not know from the video, but a compound is 2 or more elements chemically combined. 2 or more elements chemically combined. And typically, not typically, but, okay, typically what's formed are what's called molecules. Okay, molecules are formed. Molecules are formed. And what the heck is a molecule? Molecule are 2 or more atoms. So, what is that? Well, if you have one little circle here, let's shade that in, that's an atom. Let's say that's an atom of Na. And we add that to one atom. So put a little circle, don't shade it in. That's an atom of Cl. If you put those together, right? 2 or more elements, that's 2 elements, chemically combined, okay? Tomorrow I'll show you a video of sodium and chlorine coming together. Since I'm not here today, I can't get it all set up with the video in that video. I can't show you 2 videos at once, it'd be kind of hard. Actually, I could show you the video in the video. Maybe I will show you that. So two elements combining to form, put these 2 together now. So they're touching, right? The two circles are touching. That means they went through a chemical reaction, and now this is called a molecule, and that's called salt, right? NaCl, salt, or sodium chloride. that's a compound, right? Here's our compound. These are elements. That's an element. That's an element. So two or more elements chemically combine to form a compound. Also a molecule. So what is a molecule? Two or more atoms touching, right? That's a molecule. Compound, two or more elements. It's almost the same thing. Almost the same thing, except you can have molecules that are elements, like the diatomic elements, H2, O2, N2, Hankelbriefs, right? We'll talk more about that down the road. So that's a compound. Two or more elements chemically combine. Molecules are formed. Put a little star here. Compounds can be broken down. Compounds can be broken down into their elements, right? Parentheses, into their elements. So yeah, compounds are not the building blocks of matter, elements are, because you need elements to make a compound. Compounds can be broken down. How can they be broken down? Chemically. You can't take a real little super sharp knife and slice salt in half and get Na, sodium metal, and chlorine gas. It doesn't work. You got to chemically break it down, like running electricity through it would be an example. Okay? So here's salt. This is salt. Okay, everyone knows what salt looks like? NaCl. This is a compound. Notice, it's all the same. It's all identical. This might be harder to see on the video, but that's your copper chloride. You saw that in lab. All looks the same. So compounds like elements, I'm going to squeeze it in actually, you know what? Oh, wait. I'm going to make sure you can see it. I can't tell. But compounds, just like elements, are uniform. Okay? They're uniform. So I'll give you 30 more seconds to get this down, and then I will write down the last couple parts of the notes here. And then I am going to show you this video of I think it's a teacher who reacts these to form salt. So I'll show you how it's a definite, obvious chemical change that forms salt. Okay, that was more than 30, but you should be good to go. So now, this is still on compounds. Another star. Compounds have uniform composition. Think of water, okay? I don't have see-through bottle here, but water's in here. You know what water looks like. All water from your tap or filtered water from a bottle, whatever, all the water basically looks the same, right? Uniform composition. Water's a compound, right? Water's a compound. Let's see. Compounds have properties that are different than the properties of the elements that make it up. So the elements that make up a compound have different properties than the compound because they go through a chemical change. I talk about sugar. Sugar is C12H22O11, solid. Sugar is sweet, right? Tastes sweet. It's white. It's a solid, right? Solid crystals. Kind of looks like the salt here. Kind of looks like the salt. So sugar, sweet, white, solid. It's not flammable. You can burn it. If you cook it too much, you can melt it, but it's not flammable. Not flammable. Okay, these are all separate. But if you look at the three elements that make it up, carbon, hydrogen, oxygen. Carbon is a black solid. Tastes like crap too. It's like eating a piece of charcoal. Hydrogen, colorless. Gas, same thing as oxygen, colorless. Gas. Guess what? Hydrogen, oxygen, flammable. I hope you can see that. You should be able to. Oxygen, hydrogen are flammable. They can be lit on fire. They burn. Colorless, they're gases. Don't really have a taste. What I'm trying to prove is that carbon, hydrogen, oxygen are in sugar. Sugar is the compound. Properties of compounds are different than properties of the elements. Properties of the compound, it's a solid, it's white, it tastes sweet, we eat it, right? It's not flammable. But these three, we don't eat any of them. Yeah, we breathe oxygen, we don't eat it. Okay, carbon, hydrogen, oxygen, we don't eat them. Why? They don't taste good. Carbon tastes terrible. The colorless gas here, hydrogen and oxygen, again, we don't eat it, but if we were to taste it, there is no taste. Different, right? Different property. This is solid, but that's just a coincidence. Solid gas, different property. They burn, they're flammable. This is not. So whenever these go through a reaction to form a compound, elements, they form a compound, the properties are different. The properties are forever changed. Properties have changed. Okay, 30 seconds, I'll have you write that down. I'm running out of time actually. I'll put your homework on the board behind me. I'll also tell the sub though. Page 52, 20 through 27, page 58, 48 through 52. Put that on separate paper. I'm going to check that tomorrow. It's in your book. Okay, so that's homework. So unfortunately, I think I'll have to show you that video with the production of salt, making salt through a chemical reaction tomorrow, just because I got another class coming in like a minute. So hopefully you've had time to copy that down. That's your homework. I'm going to shut this off now. I'll see you guys tomorrow.